Okay, good morning. Want to go through three things today: bubble sort, stack data structure, and linked list data structure. So, let's go with bubble sort as a sorting method to either sort something in a descending or ascending order. So, let's have okay, that's your that's your list. So bubble sort uses two for loops. So if list of I less than list of j, you have to use two for loops because given an array like 2 3 4, you have to compare 2 to 3. You can do this using one for loop, like by taking ith index and I plus 1th index, but then there will be only one flow through the entire array. You need multiple flows, like first it'll be 2 to 4, then it'll be 3 to 4, it'll be 1 to 4, and last it'll be 4. So for each iteration, suppose first you'll compare 2 and 3. In this case, 2 is less than 3, so you can swap. That's how it works. So initialize a temporary variable. You can figure out the temp swapping in your mind, or just use two variables and a temp variable. So that's basically it. Let's see if it worked by printing before and after. So as you can see, it's now sorted in descending order. Suppose you want it in ascending order, all you have to do is change the equality sign. Now you can see sorted in ascending order. So that's basically bubble sort. So it's one of the sorting algorithms. The time complexity is O of n squared. So what that means is big O notation is something that computer scientists use for calculating time complexity. So since one for loop for an array, there will be n runs. So second for loop, there will be another n runs for each run of the first array. So it's n squared. So this is bubble sort. So now just let's move on to, there's an inbuilt Python sort function also. You can obviously just use that. Let's move on to stack data structure, or let's let's do stack. So stack is basically last in, first out. There are two types: first in, first out, that's queue data structure, and last in, first out, that is stack data structure. Stack is just like a stack of plates. You have to take out the last plate first, obviously. Just now you have list already, so just let's just use list. So okay, now you want stack insertion. I'm not going to implement the class based method right now. So stack insertion, you can just use list dot append 10, 12, whatever. So this is stack insertion. As you can see, all of that is inserted to the end, so you have like a mini stack in implementation in Python. Now stack deletion, so you can just use list dot pop. I'm unsure if that syntax is perfectly right, so let's just check. Yeah. So it popped the last, like that you can pop everything. So that's basically stack data structure. Now let's move on to linked list data structure. So what is a linked list? Linked list is basically something that has nodes. Each node will have a value and a next pointer, which is a pointer to the next item in the linked list. So we can try implementing that. Linked list. So you need two classes, class node so obviously self keyword like we talked about yesterday, and the value of the item, self dot self dot val equal val, and self dot next, that's the next pointer. Excuse me, dogs are barking, I can't do anything about that. Okay, that's your class node basically. And now you need a class, I'm just gonna name it LL. So my algorithm won't be perfect, mind you, but mostly it'll work. You just need a self there, and you need self dot head equal none, because every linked list has a head and a tail. The head is the first node and the tail is the last node. Only the tail node points to none. We'll get to that. Now let's do insert a val. So you have to create a node basically. So node with val, if head, if not head, that's a better way to write it. That means if there is, I can't use head, that would be wrong. I have to use self dot head, and I did not put the self keyword here. If not self dot head, self dot head equal node, then you can do a return here. So another case, while it's not perfectly efficient, but it will work, mind you. I could have done all of it in one while loop, but my understanding is not perfect. So while current means if there is a current. While current, if current dot next is not equal to none is what you should understand it as. So here while current not equal to none, same thing. If current dot next is not equal to, if current dot next exists, else current dot next equal Let's see if this works or there'll be some error, which I'm sure. ll equal to ll dot insert 10 11 12 13. Got stuck in an infinite loop. I think the right thing would be to do current dot next. Wait a minute. Okay. So that executed. So all of this got inserted. Now let's just try. Print ll dot head dot val. It's 10, which is right. So now ll dot head dot next dot val. So there is an error in my program. It's linking to the none type basically. Only self dot head got let's just try it for some more time. So let's one way to easily debug. Usually the right way is actually to use a debugger. This must be a small error somewhere. I'll try to do it for another 1 minute. For another 1 minute I will try, then I will look at the solution. Basically you have to do this only. Current equal to self dot head. So while current dot next is not none or current is not none, this might lead to another infinite loop. Yeah, it did. Current dot next is not none. Current dot next equal node and return current equal dot none type object has no attribute val. Let's look at the solution. Always remember that I faltered right now, so it's very normal to falter. Once you look at the solution, everything will become all right. So I've written LL, that's why it didn't come. I'll see where I went wrong. So let's see, insert. Where is the insert? and then while next while last or next while last or next one. Okay. 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 I did something stupid. That's why. Let's see if this works. So, I didn't prepare for this beforehand. That's why I'm making mistakes. Let's see if this leads to an infinite loop. Great. And this is also faltering. Let's try another algorithm which I can understand more, and let's just ask GPT. Okay, GPT printed it out. Append, display, delete, append. So if not self.head, okay, return current equal to self, while current dot next, current equal to current dot next, current dot next is, what's wrong with my algorithm? Seems right. While current dot next, current equal to current dot next, current dot next is equal to new node, while current dot next. Okay, same thing is happening. Wait a minute. Ugh. That's why. So now you can see it started working. That was silly of me. But what to do? So I just wanted to try it novel, just to show you that you also have to try it like that. Even if you look at the algorithm, you have to understand it. I can explain linked list one more time. Excuse me for faltering actually. But what to do? Sometimes. So that is the end of the list. So you can see none. Okay, node object. So what is none there? Okay, next will be none. Here next might be none. Okay, wherever next is none, it is none. So now we have the last item inserted. Here obviously there is no node after this, that's why that error came. Node object, it's linking. Okay, so let me explain linked list again. You need a class node with constructor with val and next. So define a class linked list, set head to none, define insert node is equal to node val. That means you're instantiating that class and creating an object node of that class. If not, self.head means if there is no head, insert to the head and return. So next, initialize a current variable to self.head while current.next. That means if there is something after what is there already, move forward, else insert the new node in the next pointer of the previous node. That is all there is to it. Okay, I took some time, so I'll write it in the comment saying where you should actually start or stop. Thank you.